Hi everyone! Today we're going to solve LeetCode problem number 2. Add two numbers. The key takeaway for this problem is practicing the dummy head approach. With that said, let's go ahead and get started. So this is LeetCode problem number 2. Add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zeros, except the number 0 itself. Alright, so let's look at the examples they give us. So in example 1, we have a linked list with nodes 2, 4, and 3, and a linked list with nodes 5, 6, and 4. And their sum is a linked list with nodes 7, 0, and 8. So because the digits are stored in reverse order, the 2, 4, and 3 represents the number 342, and the 5, 6, and 4 represents the number 465. 342 plus 465 is 807. So the sum is 807. 807 reversed is a linked list with nodes 7, 0, and 8. In example 2, both L1 and L2 are 0, so the output is just 0. Finally, in example 3, L1 is 9,999,999, and L2 is 9,999. And the output is a linked list with nodes 8, 9, 9, 9, 0, 0, 0, and 1, which represents the number 10,009,998. Alright, so this example is probably meant to demonstrate that we do have to deal with a carry if two digits add up to be more than 10. And because of the carry, our solution may end up containing an extra digit. Okay, so it looks like the examples provide a good range of inputs. In the first example, both L1 and L2 had the same number of digits. Example 2 is an edge case where we add 0 and 0 to get 0. And in example 3, we have to deal with a lot of carry, and L1 and L2 are a different number of digits. Okay, so given that we have such a good range of inputs provided to us, I don't have any additional clarifying questions to ask. So let's move on to the planning phase. So in this problem, we have to add each of the digits. And we're probably going to do it by adding the digits iteratively one by one, the same way we'd add numbers in our heads. So since we're taking an iterative approach, that probably means we're going to use a dummy head. In this case, the dummy head is helpful because we can use it to build our output linked list, and we don't have to treat the head of our output list as a special case. We can just create the dummy node and then add all our nodes to the end of the list we're building, one by one. We don't have to treat the head node any differently. So the first step in our plan is to create a dummy head. And we're going to end up returning the dummy head's next node as our solution. Alright, so let's get started with brainstorming the rest of our solution. The example I picked to brainstorm with is 99 plus 65, which equals 164. And I drew it out the way we typically see this type of addition. So the numbers are in the correct order, but the arrows of the linked list are reversed. This is just to make things easier for me because that's how I'm used to adding numbers in my head. Alright, so I picked this example to brainstorm with because number 1, it involves a carry since 9 plus 5 is 14, so we'd have to carry that 10 over to the next digit's place. And secondly, it leads to the addition of a new node in our output. So 99 plus 65 is 164. So we have to add that 1 in the hundreds place, whereas we didn't have a hundredth digit in L1 or L2. The reason why I didn't use the last example they gave us, which also had these properties, is because that one was just too long to brainstorm with. Alright, now that we have a good example and a dummy head, let's continue on formulating our plan. Alright, so the next step of our plan is to create a carry variable and initialize it to 0. We'll need this carry variable in order to perform our addition. We also need to add a variable to track the L1 digit that we're currently on. Let's initialize this L1 digit to L1. And we also need to add a variable to track the L2 digit we're on, and we can initialize this variable to L2. And the last variable we need is an output end variable to track the end of our output list so we can keep on adding nodes off the end of our output list. We can initialize this variable to our dummy head. Now that we have all our variables, we can finally start performing our addition. Let's add an output digit equal to the sum of L1 digit, L2 digit, and the carry modulo 10. In this case, 9 plus 5 is 14, and 14 modulo 10 is 4. So we add an output node with the value 4. Next, let's update the carry variable to the sum of L1 digit, L2 digit, and the carry floor divided by 10. In this case, 9 plus 5 is 14, and 14 floor divided by 10 is 1. So our carry variable is now 1. Then, let's update the rest of our variables accordingly. So we shift L1 digit, L2 digit, and end node 1 node over. And then, we keep on adding digits and repeat steps 3 to 4 until there are no more digits left of L1 or L2. So we set the new output digit to L1 digit plus L2 digit plus carry modulo 10, which is 1 plus 9 plus 6 modulo 10, which is 6. And we update the new carry variable to L1 digit plus L2 digit plus carry floor divided by 10, which is 1 plus 9 plus 6 floor divided by 10, which is 1. Finally, if there's an extra carry left over, we need to create a new node for it and add it to our output. Alright, and that's it. Recall from the first step that we return the dummy head's next node, so we return the linked list with nodes 4, 6, and 1. Here's our plan all written out. Now that we have a solid plan, let's start translating it into actual code. I've copy-pasted our plan into our text editor so we can start coding up our solution. So the first step is to create a dummy head. So let's go ahead and do that. And we will end up returning the dummy head's next node as our solution, so let's also go ahead and do that. Step 2 is creating a bunch of variables. So we create a carry variable, which we initialize to 0, an L1 digit variable, which we initialize to L1, an L2 digit variable, which we initialize to L2, and an output end variable, which we initialize to our dummy head. Alright, and step 3 of our plan is to add an output digit of L1 plus L2 plus carry modulo 10. And looking ahead, we can see that step 4 also uses the L1 digit plus L2 digit plus carry in its computation. So let's just go ahead and store this value as a new variable called total to avoid computing this twice. So our new output digit is total modulo 10. And we update the carry variable to total floor divided by 10. Alright, and for step 5, we update our L1 digit, L2 digit, and end node variables. So let's just move all those nodes forward by 1. And then we need to repeat steps 3 to 4 until there are no more digits left of L1 or L2. So let's move some of this code into a while loop, and we want to continue this while loop while there are still more digits of either L1 or L2. Okay, so this adds a little bit of complication into our code, since at any given point, L1 digit or L2 digit could be none, since L1 and L2 might not have the same number of nodes. So L1 might run out of nodes before L2, or L2 might run out of nodes before L1. So in order to avoid errors, anytime we use L1 digit or L2 digit, let's first check to make sure that they are not none. All right. And our last step is, if there's an extra carry left over, create a new node for it in our output. So if carry is greater than 0 by the time we enter out of our while loop, we add a new node to our output to hold our carry variable. And that's it. That's the end of our code. Let's run it on our example test cases just to make sure it's a solid solution. I'm already pretty sure that our code will work on example 1, since the case we used to brainstorm our plan also had the same number of digits for L1 and L2. However, example 2 looks like a bit of an edge case, so let's try running through our solution with example 2. For example 2, L1 is 0 and L2 is also 0. Our carry variable is initialized to 0, and our end node is initialized to our dummy head. In the first iteration of our while loop, total is the sum of our L1 digit, L2 digit, and carry variables. Since they're all 0, the first digit we add to our output list is 0. And after shifting our L1 digit and L2 digit variables over by one node, we hit the end of L1 and L2 and terminate out of our while loop. And we return the dummy head's next node, which is 0. So this test case checks out. Let's do example 3, which is a little bit more complicated. So L1 digit starts off as 9, and L2 digit also starts off as 9. The carry starts off as 0, and our end node starts off as the dummy head. In the first iteration of the while loop, the total value of L1 digit plus L2 digit plus carry is 9 plus 9 plus 0, which is 18. So the first digit we add to our output is 18 modulo 10, which is 8. And we update our carry variable to 18 floor divided by 10, which is 1. In the second iteration of our while loop, the total value of L1 digit plus L2 digit plus carry is 9 plus 9 plus 1, which is 19. So the second digit we add to our output is 19 modulo 10, which is 9. And we update our carry variable to 19 floor divided by 10, which is 1. The same goes for the third and fourth iterations of our while loop, so we add 2 more 9s to our output list. By the fifth iteration of our while loop, we have run out of digits of L2, and so our total value is L1 digit plus carry, which is 9 plus 1, which equals 10. So the fifth digit we add to our output is 10 modulo 10, which is 0. And we update our carry variable to 10 floor divided by 10, which is 1. The same goes for the sixth and seventh iterations of our while loop. So we add 2 more zeros to our output list. Then L1 runs out of digits, but we're still left with a carry variable of 1. So we create a new node for the 1 in our output. Finally, we return our dummy head's next node. So we return a linked list with the nodes 8, 9, 9, 9, 0, 0, 0, and 1, which matches our expected output. Alright, so it seems like this is some pretty solid code that at least works on our test cases. So now let's run it on all the test cases to make sure it fully works. Okay, and we can see that it passes. So now that we have working code, let's evaluate the time and space complexity of our solution. So the time complexity is the maximum number of digits between L1 and L2. And the space complexity is the maximum number of digits between L1 and L2 as well. This is because the number of digits in our solution is the max number of digits of L1 and L2 plus 1, since we might have that extra carry node in our output. But in big O analysis, we drop lower order terms. So we drop the plus 1 and we end up with a big O of the maximum number of digits between L1 and L2. So this affects the time complexity because we are creating the digits of our output one digit at a time. And it affects our space complexity because we have to create a node for each digit in our output. Alright, that's it for today's problem. LeetCode problem number 2. Add two numbers. Again, the key takeaway for this problem was getting practice with the dummy head approach. Hopefully this was helpful for you, and thanks for listening.